Alrighty, so we are starting a brand new unit, and it is going to be on rationals. Okay, well, rationals is literally just a fancy word for fractions. They're the same thing. Okay, so part of today you are going to see that these polynomials and these expressions will be written as fractions. So today we're going to do some more practicing of factoring and then dealing with factoring when they're in fraction form. Okay, so let's go ahead and look at number 1. For numbers 1 and 2, it just says factor each completely. Okay, well in number 1 we have two terms. This is a binomial, so we want to decide, does it have something in common? So we want to look at our coefficients first. I have 2 and -2. Well, that's not too hard. I know that they have a 2 in common. I can factor out a 2. Okay, so then we look at our variables. I have 3 m's right there, or m cubed, 2 m's right there, m squared. Remember, we can take the lower amount out, so I can factor out m squared. Okay, so then inside the parentheses is just what's left over when we divide out this greatest common factor. Okay, so I have 2m cubed divided by 2m squared. Well, 2 divided by 2 is just 1. And then m cubed divided by m squared, think I had 3 m's, I took away 2. I'm just left with 1m. We don't have to put the 1 in front. Okay, well now I have -2m squared divided by +2m squared. -2 divided by +2 is -1. And then I had 2 m's, but then I divided 2 away, so I'm just left with that 1. So final answer, factored, is 2m squared times m minus 1. Beautiful. All right, let's look at number 2. Okay, so this time we have a trinomial, meaning 3 terms, but same rules apply. We want to see if they have anything in common. So this guy has 4 n's, this guy has a 2 and 3 n's, this guy has -3 and then 2 n's. So they actually have, all of them have some n's. Okay, so remember, you can take the smallest amount. So we can actually factor out our smallest amount, which is n squared. Okay, so now let's figure out what's left inside my parentheses. Okay, well we had n to the 4th divided by n squared. Think 4, take away 2. I'm left with 2. Okay, and then in my middle term I had 3 n's, take away 2. I'm left with 2 and then 1 n. And then -3n squared divided by n squared, I'm just left with the -3. Okay, so we were able to factor out the n squared, but we're still not done factoring completely, because now we can play the number game with these guys, meaning I need two numbers that'll multiply to -3, but add to +2. Okay, well, there's only a couple options to get me -3. That's going to be 3 and a 1. But then to get +2, I want the 1 to be negative, because 3 minus 1 gives me +2. Okay, so my final answer, can't forget that n squared that we factored out before. Then in parentheses, I have n plus 3 for +3 times n minus 1 for -1. And there we go. We are factored completely. Okay, so those two were just kind of reviews on factoring. So now we'll see that the rest of our examples for today are going to be factoring. We have these expressions, but then it wants us to simplify because they are in fraction form. Okay, these are what we call, again, rationals or fractions. Okay, so first thing, we just want to look and see if either the numerator or the denominator can be factored. So let's go ahead and look at the numerator. I just have, so ignore the denominator, I just have n plus 3. Okay, well, I cannot factor n plus 3. It is as simplified as it'll go. Okay, so on top, I'm just going to write it n plus 3. Okay, now on bottom, we can simplify this guy. This is a trinomial that we can play the number game with. So we want to think, what are my two numbers that multiply to 21? but add to 10. Okay, well I know I can divide 21 by 7. That would be 7 times 3. 7 plus 3 does give me that 10 I'm looking for. So there we go. Okay, so we found our two factors. So that means on bottom I have n plus 7 and n plus 3. Okay, well on top I'm going to put some parentheses around these guys. Okay, now what we want to do when we're simplifying fractions, remember if anything is the exact same on top and bottom, we can cancel it out. So it has to look the exact same, meaning inside the parentheses has to be the same. Well, I see that n plus 3 and n plus 3 can cancel out. So remember, when nothing is left on top, we have that invisible 1 that's left on top, and then on bottom, we're just left with n plus 7, and that's our final answer. That guy is fully simplified. So we were able to factor and then cancel out anything that was the same on top and bottom to get our final simplified answer. Okay, let's go ahead and do that again. Okay, so look at our numerator. This is not a trinomial, so then we want to think, do these guys have anything in common? Okay, well first I want to look at 14 and 70, and I'm just going to see if we can divide 70 by 14. Okay, and we can. Nice. So that means we can factor out a 14. Okay, and then we also want to look at our variables. This guy has 2 x's, this guy has 1. I can factor out the smaller amount, which is just 1x. And now I figure out what's left inside. Okay, well 14 divided by the 14 is just the 1. 2 x's take away 1x is just going to leave me with 1x. And then I just decided in my calculator, I saw that 70 divided by 14 was positive 5. And then I had 1x, but I took it away, so there's no x's left with that. Okay, so now on bottom, this guy is not really factorable. He's just 63x. So we're not going to really factor him. But now what we can see is if anything cancels or reduces on top and bottom. Okay, well I see that an x and an x can cancel. Now, here's what's important. We cannot cancel that x. If it's inside the parentheses like this, you cannot cancel it with one that's just sitting by itself. X is different than x plus 5. Okay, so those x's can cancel, but then I can reduce 14 and 63. I can divide both of those guys by 7. So 14 divided by 7 would give me 2. 63 divided by 7 would give me 9. Okay, which cannot reduce any further, so we know we're good there. And then on top with the 2, I still have x plus 5. So final answer, 2 times x plus 5 over 9. Beautiful. Alrighty, number 5. Okay, so let's go ahead and look at our numerator again. So I have 15 and 30. Okay, again, 2 terms. We just want to see if there's anything they have in common. Okay, well 15 and 30, I can divide both of those guys by 15. So I can factor out a 15 on top. They both don't have n's, so I can't factor out an n. So I'm just left with 15 divided by 15 is 1, so 1n. And then 30 divided by 15 is 2. Okay, then on bottom, I have 20 and n squared. Okay, so there's no n plus 2 and n's, right? I cannot cancel those n's because one's inside the parentheses, one's not. So you can't cancel anything there. The only thing I can reduce, think reduce fractions, I can divide 15 and 20 both by 5. So 15 divided by 5 would give me 3. 20 divided by 5 would give me 4. On top, I'm still left with n plus 2. On bottom, I still have n squared. So final answer, 3 times n plus 2 over 4n squared. Awesome job. Okay, number 6. Our numerator cannot be factored. Okay, so we're just going to leave it as 15b. But then my denominator, right, 6 and 6, well, that's easy. They share a 6. We can divide a 6 out of both those guys. And then b squared and b, I can take the smaller amount, which is just 1b. So 6b I can factor out. Okay, well, 6 divided by 6 is 1. 2b's take away 1b is just 1b. And then again, 6 divided by 6 is also 1. B, take away the 1b, so we're just left with 1. Okay, so we're factored. Now we just want to see if anything cancels out, if we can reduce this guy. Okay, well, I have a b on top, b on bottom. Those guys are just standing alone. And then I can reduce 15 and 6 because I can divide both of those guys by 3. 15 divided by 3 is 5. 6 divided by 3 is 2. And then on bottom, I still have my b plus 1. So final answer, 5 over 2 times b plus 1. Awesome job. All right, number 7. Okay, so again, let's look at our numerator. Can't factor this guy because they have nothing in common. We're not playing the number game. So on top, we're just left with n plus 9. And I'm going to go ahead and put parentheses around him. And then on bottom, we can factor these guys. Okay, 5 and 45. The biggest number I can divide both of those guys by is 5. So I can factor out a 5. Can't factor out an n because both of them don't have an n. So then we're left with 5 divided by 5 is 1. By my n. 45 divided by 5 is 9. Okay, so it's all factored. Now we just need to see what cancels. Okay, well, the exact same on top and bottom. I see an n plus 9 and an n plus 9. Remember, they have to be exactly the same if they're inside the parentheses. So the invisible 1 is left on top. Remember, when it's on top, it's that invisible 1. And on bottom, I'm just left with the 5. Great job. Okay, number 8. My numerator. Okay, I can factor this guy by playing the number game. Okay, so give me 2 numbers that are going to multiply to positive 10, but add to negative 7. Okay, well, I'm thinking a 5 and 2 would probably give me 7, but I need it to be negative 7, so I'm going to make both these guys negative, because a negative times a negative still gives me a positive. When I add them together, that does give me the negative 7 I'm looking for. Okay, so that means my 2 factors on top are b minus 5 and b minus 2. Okay, then on bottom, I have 2 minus b. Okay, so here's a little trick. We see that b minus 2 and 2 minus b are almost the same. Okay, they're just switched. The signs are switched. This is a positive b and a negative b. This is a negative 2 and a positive 2. Well, when that happens, when it's the exact same, only flipped, like these two are, they actually reduce to a negative 1 rather than a positive 1. They're almost the same. Their signs are just flipped. So what we actually have is negative 1 on top times b minus 5. And you could distribute that out, but we're going to go ahead and just leave it like that. Negative 1 times b minus 5. Beautiful. 2 more. Number 9. Let's go ahead and factor my numerator. Okay, look at your coefficients, your numbers. 15 and 35. Well, 15 doesn't go into 35, but I know 5 does. Okay, so I can divide out a 5 out of both these guys. Okay, can't take an r out because they both don't have an r. So then I'm left with 15 divided by 5 is 3, and then my r. Negative 35 divided by 5 is negative 7. Okay, and it's all over 25, which we can't factor. We just leave as 25. Alrighty, so now we just think, is there anything the same on top and bottom, or can we reduce it? Well, 5, I can divide by 5, and 25, I can divide by 5. So I'm going to reduce that. 5 divided by 5 is 1, and then I have my 3r minus 7 on top. And 25 divided by 5 is 5 on bottom. Technically don't need to write that 1, but that's okay. And there we go. Okay, so let's go ahead and factor our last guy, simplify our last guy. Okay, so my numerator, I have 20 and 20. Well, 20 and 20 are the same, so we can factor out a 20. Okay, can't take an x out because they both don't have an x, so I'm just factoring out the 20. Okay, 20 divided by the 20 is 1, so 1x. Again, 20 divided by 20 is 1. So I'm left with 20 times x plus 1 on top over 8x on bottom. Okay, anything the same on top and bottom, or can we reduce? Remember, we cannot grab the x inside the parentheses and cancel it with that x. That's not the same. This is x plus 1, that's x. Those are not the same. Okay, so the only thing I could do here is reduce 20 and 8. Well, the biggest number I could divide both of those guys by is 4. I can divide 20 by 4, and I can divide 8 by 4. 20 divided by 4 is 5. 8 divided by 4 is 2. On top, on top I still have x plus 1. And on bottom I still have the x. So there's my final answer. Okay, before you work on your assignment, let's go ahead and write the steps for simplifying. Our first step was to factor if possible. Okay, so look at both the numerator and the denominator and factor if possible. And then the second step was to cancel if they're the exact same, or reduce, just like reducing fractions. Okay, and those were our steps. So there you go.